Okay, this week's topic is if statements and random numbers. What is an if statement? Well, let's start by saying that an if statement is a tool that we have as programmers to write code that will run only under certain circumstances. Until now, everything that we have coded executed no matter what. Now we're going to have a condition that is going to help the code decide whether certain code should execute or not. So for example, we are all familiar with this example of a student that takes a course that has a pass or fail system. So normally, if the student scores 70 or more, the student passes, otherwise the student fails. Whenever you have a situation like that you speak in conditional, you can use an if statement. So the condition here is if the score is 70 or more. And there are two possible outcomes. When the condition is true, the student passes because the score is 70 or more. The alternative condition is going to be false, so the student will fail in that case. The if statement is one out of three possible control structures that we have available in programming in any programming languages. So far, everything we have been doing has been happening one line at a time in the order that they appear. We call that sequence. The if statement is called selection, and next week we're going to learn the third and last control structure, that is iteration, in other words, repetition. So control structures tell the programs how to execute the lines of code. Until now, we have used only sequence, and in sequence, all the lines of code execute one at a time in the order they appear. So for example, when we had in a program the two lines of code, number equals 3, the value 3 is assigned to the variable named number, and after that, the value stored in number will be displayed to the screen. So we're going to see 3 on the screen because those two lines of code happen in that order. Selection will allow us to select whether to do or not to do something, and that is the if statement. Here we have the first example that you're going to complete for the practice with me exercises of this week. You're going to code this little program and you're going to run it using the value 70 and the value 59. Sorry, there is a typo there. There's a disagreement between the title and the value that I assigned to the variable. So the code is the same, but what has changed is the assignment for the score. So in the first program, you see score equals 70, and it reads, if score is greater than or equal to 70, colon, that's a colon, don't forget the colon, otherwise it's not going to work. If that is true, print, and the output statement is the same as always. So single quote, congratulations, you passed the class. Else, so go to the next line, else, colon, print, please plan to retake the class. Close parentheses, next line is not indented, so when it's flashed to the left, it means that it's outside of the control structure. Print aloha. So regardless of the condition, true or false, we're going to see aloha. If the score is 70 or more, we're going to see congratulations, etc. If it is not greater than or equal to 70, we're going to see the alternative outcome, please plan to retake the class. And regardless of the condition, we'll see aloha. It is important that you notice the indentation. And we'll talk more about indentation in another exercise. So for the time being, please code this with the change in value for score and run it with each one of the two values. Take screenshots, put them in a Word document, and that's going to be the beginning of your practice with me exercises for the week. So that's going to be your running document. So this week we're focusing on the if statement, and next week we're going to add the very last control structure that is called iteration. Iteration is another word for loops. What a loop means is that we can ask Python to repeat a certain line or a few lines of code over and over and over. The different ways to say that, there are different styles of loops. There is something that is called the for loop, another one that is called the while loop. So those are the keywords that we're going to use for the loops. And certain types of loops are better for certain cases. We are likely to practice only one type of loop or focus on one type of loop given our time constraints. But whenever you find yourself repeating lines of code, copying and pasting, copying and pasting, copying and pasting the same code, please know that you're very likely to need or save your time by using a loop. So to sum it up, there are three control structures which represent how the lines of code will execute. Sequence, every line executes one at a time in the order they appear, and that's the way we have been coding until now. Selection is what we're practicing this week. The if statement is an example of selection control structure, and it means that we can tell the program whether to do something or not depending on a condition. And finally, iteration means that we can repeat lines of code. So rather than retyping the code, we use a control structure that tells the programming language to repeat that a certain number of times or until a certain situation is true. So focusing on the if statement, the first thing that you want to understand and be clear of is the syntax. What does Python itself expect us to use in the structure of the if statement? So Python understands that as such. So we start with the keyword if, hence the name if statement. Then we're going to have to spell out a condition, and after the condition we're always going to have colon. So don't forget the colon, that's a little tricky at the beginning. Here's an example of an if statement. If grade is greater than or equal to 70, colon, print, congratulations, you passed. So this is coming exactly from the exercise that I assigned you to code. So you may be familiar with this by now. So here you have if is a keyword, grade greater than or equal to 70 is the condition, and then you follow up with colon. Whatever is in the next line needs to be indented. If it's not indented, it's not considered inside the if, so you're going to have issues. And it is very important that you use the same symbol or the same keystroke to indent. I recommend that you use the tab key consistently every time that you want to indent. That way you don't have issues. Python has problems if we change what symbol, what keystroke we use to indent our code. So to us, it looks like it's indented, but Python gets confused if we alternate between the tab key and the space bar for the next line. So if grade is greater than or equal to 70, colon, print, congratulations, you passed. So we start with the keyword if, we follow with the condition using the relational symbols, and I have a slide for that. So we review all the combinations that we have available, and we end with the colon. The executable line or lines of code need to be indented when they belong inside the if, meaning the lines that we want to execute only if the condition is true need to be indented so Python knows that they're part of that condition. So here is a slide where I sum up for us a review of the symbols that we have available in Python, how we read them, and an example of how we use it. So these are all the symbols that we have to compare two values. Relational symbols are greater than, so for example, score greater than 70, less than, score less than 70. Double equal is for equality. We need to use double equal because a single equal is used for assignment statements. So Python will not allow you to have a single equal sign in the condition, but in other programming languages, you can have a single equal sign. And what it means is that you are assigning that value to the variable at that moment, and that condition will be true. So we have to be careful about that. In Python, you're not going to be allowed to make that mistake or have that accident, but it is important to understand that in other programming languages like C or C++, you are allowed to use a single equal sign, and you're doing two things at once. You're converting the value to that value that you are assigning, and the condition will always be true because you're assigning that value. In our case, double equal sign is for equality, and then greater than or equal to, that's how we spell it out with the two symbols. So score greater than equal to 70, the opposite less than or equal to, score less than or equal to 70, and then it's a little bit peculiar because we don't have a way to cross out an equal sign to represent the inequality. So what we do is we precede the equal sign with exclamation point, and that signifies not equal to. So score exclamation equal sign 70 means score not equal to 70. I recommend that you make a cheat note with all these available symbols for the condition, just in case this is difficult for you to remember on top of your head. That way you have a little crutch next to the computer when you're coding if statements of your own. A program can have multiple if statements. So for example, we can check if a value is positive, even, larger than 100. And notice that these three possibilities, they can coexist in a number. So for example, the value 120 fulfills all the three conditions. 120 is positive, it's even, and it's larger than 100. So when the different conditions that we need to check for, they are not mutually exclusive, meaning that they can be present at the same time, we use independent if statements. So rather than having an if, blah, 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 else, blah, 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 like the example that you already coded, you could have independent if statements without an else. So if number is greater than 0 to find out if it's positive. If number is exactly divisible by 2. If number is greater than 100. So when the conditions are not mutually exclusive, we spell out independent if statements. Here is an example. I ask that you please code this. This is your exercise number 2. In which you are practicing independent if statements. So we start with number equals to 459, and we have 1, 2, 3, 4, 5, 6 if statements that check for different options, different characteristics for that number, and displays a message related to that when the situation is happening. So for example, if number is greater than 0, print number is positive. If number modulus 2 is equal to 0, it means that that's an even number, because when modulus 2 gives you 0, it means that that number is exactly divisible by 2. So that's how you check if a number is even. Number modulus 2 equals 0. Print number is an even number. Next, if number modulus 3 is equal to 0, colon, print number is exactly divisible by 3. Next, if number modulus 5 is equal to 0, print number is exactly divisible by 5. And now different conditions. If number is greater than 100, print number is larger than 100. And if the number is less than 1,000, print number is lower than 1,000. When we run this program with the value that I suggest in the declaration, 459, 459 is positive, it's exactly divisible by 3, it is larger than 100, and it is lower than 1,000. But notice that it is not even, so it didn't display that, and it's not exactly divisible by 5 either, so it didn't display that. So I ask that you please code this program and you run it with different values. Try some values that that fulfill different characteristics. Maybe put a negative number, put a value that is larger than 1,000, use a value that is exactly divisible by 5 and 10, but not by 3, etc. So run it good 4 or 5 times so you see different options of the different if statements that can alternate. So what it means is that when this program runs, each one of the conditions is checked for, because each one of those conditions is written in an independent if statement. So it means that those conditions can coexist in the number, so they are not mutually exclusive. A lot of times, conditions are mutually exclusive, meaning when one is true, the other one will not happen. For example, a student passes or fails. A student cannot do both things, pass and fail, in the same course. So if when one condition is true, the other condition or conditions are not possible, we say that those conditions are mutually exclusive. One is true, makes the other ones false. When that is the situation, we would not write independent if statements like this example that you just coded. We would use an structure that is called the if-else, if it's only 2 alternative outcomes like the pass or fail. Or you could have more cases, and in that situation, you would use an if-else statement. The advantage of using this rather than independent if statements is that when the program executes, once that the first condition is true, the others will not be even checked for. This will be your next exercise in the Practice With Me lab this time. So here's an example. I was thinking about something current, and at HPU they're going to have this protocol for face-to-face classes if HPU continues with this plan. So at the beginning of the day, the students will have to measure their body temperature, and I'm sure you're familiar with that protocol. Is done in many places around the world right now. So rather than having a thermometer, because we don't have that available right now, we would type it in. So it will be as if we read it and we type it in. So body temp equals input, what is your current body temperature? Now, we want to write conditions with this number. So to do that, we're going to have to convert that to a number. And body temperature normally has decimal places, so whatever is typed in is going to be converted to a float. So body temp equals float body temp. If the body temperature is less than or equal to 98.6, the token will be green for that day, and we're going to display the green pass, free to attend classes. Else, so if the temperature is not less than or equal to 98.6, the token will be red, and we're going to display, sorry, you get a red token today. Please attend online today. Regardless of the condition, because the next print statement is flash to the left, thank you for scanning your temperature today. So we should always have some kind of line of code after the if statement, just in case we create a scenario that doesn't fulfill any of the conditions, so then nothing will happen. Here I have my outcome with the temperature at 96 and my temperature at 100. So what is your current body temperature? 96. I get a green pass, free to attend classes. Thank you for scanning your temperature today. Alternatively, I run the same program, input in 100 for the temperature, and the program will say, sorry, you get a red token today. Please attend online today. Thank you for scanning your temperature today. Because you're going to have to do it every single day if you are planning to attend face-to-face classes in the fall. So please code this. This is your next exercise. I believe we are in exercise number 3 by now. The title for this will be if else and something like temperature example. And we're moving on to another example next. So here's an example that uses if, else if, else. So it means that we have 3 possibilities in this case. So something that we are familiar with is menus of choices. In the older days when everything we did in computers was text driven, right, and with dialog boxes and things like that, we had the person needed to type a number to signify the choice. So I'm resembling that with a menu of choices, and I'm giving the user 3 choices, 1, 2, and any other number. So the first 4 lines are output to the screen. Those are for the menu. So make your selection according to this menu of choices. 1, if you would like to know something about HPU. 2, if you would like to know something about Hawaii. Any other number if you would like to know something about Argentina. So choice equals from the input, and we prompt the user type 1, 2, or any other number. And we're going to use that as a number because we're going to compare that. So we need to convert that to an integer. So if the choice is 1, so choice equals 1, colon, we display 2 things. You chose 1, HPU, and then my little trivia about HPU. Else if, notice the way else if is contracted, or how it's spelled out. EL for the beginning of else, and if, if choice equals 2, colon, then 2 output statements. In that case, you chose 2, which is Hawaii. The capital of Hawaii is Honolulu. And then else, it means any other number. You chose neither 1 or 2, which was Argentina, and then we display something about Argentina. And regardless of the choice, 1, 2, 3, or 1, 2, or anything else, we display mahalo for playing the trivia game. So code this, change the choices to 3 things of your own rather than HPU, Hawaii, and Argentina. Select your own choices and your own trivia, maybe different characters, or maybe different car brands or models, different sports, as trivia about different cities. I don't know. Choose 3 categories of your own and make your own trivia there and run it with the 3 choices. Since this code was long, I have 2 slides for it. Here is the output, what it looked like. So I run it selecting 1. So it displays the menu, and then type 1, 2, or any other number. So I chose 1, and then you chose 1, HPU. HPU colors are Kelly green and sky blue, mahalo, and then I run it again and I typed in 2 and I gave trivia about Hawaii, and then I run it again and I typed in any other number, so I typed in a 5, and then I gave some trivia about Argentina. So you do the same with your 3 choices, and when you're done, paste the code only once, and then you can do like I did, have the 3 sample runs in one screenshot with all the different runs in one screen, and take that screenshot and paste it into the Word document. Okay, so as if we hadn't gotten complicated enough, there are cases in which we need to connect conditions using some keywords. And we use these 2 keywords for different circumstances. So we have the AND connector and the OR connector. So we use AND when we need to check if 2 conditions are happening simultaneously. For example, we may want to know if a value is positive and even, so an even positive number. So we want to know if it is, for example, 2, 4, 6, 8, etc. So those 2 conditions must be present simultaneously. So we set up the 2 conditions connected by the word AND. We may want to know if a password starts with a letter and also has at least 8 characters in it. You know, that's the frustration that we go through every time we choose a password, that different environments have different requirements of what the password needs to look like. But a very common one is that it must start with a letter and that it has to have at least 8 characters. So the conditions need to be present simultaneously because we want both things to happen. So we would check for the first character to be a letter, and at the same time, the password is at least 8 characters long. We don't have all the information to get this done yet, but just so you get your train of thought of when we would use AND to connect conditions or when we would use OR to connect conditions. Third example, if the weekly worked hours and the hourly pay are both greater than 0. So let's say that you have a program that calculates the weekly pay for the user, and the user needs to type in the number of hours that he or she worked and the pay rate that that person gets per hour. So in order for the system to be able to calculate a result, both values need to be greater than 0. Otherwise, it doesn't make any sense to multiply the values. So for that reason, we would connect those 2 conditions with the word AND, because we want to check that both are present simultaneously. Next, we may want to check if, let's say that we have a course that we want to see who needs to review, and we would invite only those people that didn't score 100 for the quizzes and for the labs. So simultaneously, we want to know that the student simultaneously has scored 100 for quizzes, so perfect score for quizzes and perfect score for labs. So we want to see who are the students that follow that criteria. So for that reason, the 2 conditions need to be present simultaneously. So we don't want any student that has 100 on quizzes but 50% on labs, and we don't want any student that has 80% on quizzes and 100% in labs. We want the students that fulfill the criteria of both having, for both types of assignments to be earning 100 average. And finally, if a value is within a range, and this is something I'm going to talk about extensively because a lot of times when we request a value from the user, we normally validate the input, and we're going to practice that quite a bit, not only now with the if statement, but also with the loop, because that's something that we normally want to do. How do we continue to run the program while the person gives me the wrong input? Well, we're going to be able to do that next week, and we're going to start to set up that situation now by learning how to spell out the condition that checks if a value is within a range, and the opposite expression to check for a value to be outside of a range. So here is an example of using AND to connect conditions. And here what we're doing is we are checking for a range of values 64 to 90. So notice what this program is doing. Let's read line by line. Print, type a number between 65 and 90, and I will tell you what letter that is. So we accept the code. The name of the variable is code, and I'm going to input from the user when the user answers this question. What is your number 65 to 90? We are going to be using that number as a number in the conditions, so we're going to convert that number to an integer. So code equals the integer of the code that was typed in. So something like the guy typed in a 55, that needs to be a number. So if the code is greater than or equal to 64, and at the same time the code is less than or equal to 90, it means that the value that the guy typed in is within the range of numbers we requested. So in that case, we are going to do something with that value. And what we're going to do is we're going to find out what uppercase letter that is. And notice this instruction. Uppercase is the name of the variable that I chose. So that could have been named potato or tomato, equals CHR. So this is a new typecasting for us that represents character. So it means a single letter, a single symbol, or a single digit from our Unicode table. Because we're working with values 64 to 90, the Unicodes overlap with the ASCII codes, so I'm going to be using the term ASCII codes and show you the ASCII table that we saw at the beginning of the semester. I'm not going to review all that anymore, but FYI. So we convert the number to a character, and then we display the code, which is the number that the guy typed in, and we tell them which equivalent uppercase letter that is. Okay? So it's going to make more sense when you run it and you're going to see it, but that's what that code does. Alternatively, is the opposite situation is when the guy doesn't type in a value within the correct range. So we need to say something. We do not want to do anything, because if the person types in a number that is not a legitimate character, then we're not going to see anything happening. So we cannot have that code execute with the wrong values, only when the value is between 64 and 90. So alternatively, we're going to say, sorry, your value is not between 64 and 90, and outside, regardless of the condition, we're going to thank the user for using this program. So here's the first sample run where I have typed in 70, and the value 70 is the code for the letter uppercase F. And then it thanks the user for running this program. Alternatively, I'm running the code with the value 100, but I am checking in the condition if the code is between 64 and 90. If it's not within the range, I'm going to display, sorry, your value is not between 64 and 90. So when you see the next line, it says, sorry, your value is not between 64 and 90. thank you for using the ASCII code converter program. So this is a program that has an if and an else using AND to connect two conditions in the if statement. So when we want to check if a value is within a certain range, we check if it is greater than or equal to the first value and at the same time less than or equal to the ending value. So please run this input this program in Python, run it with values that are lower than 64, values that are greater than 90, and values within the range. Run it several times so you can see different letters, and you can compare those codes to the ASCII code table to see if it's working correctly. So when you're done, take a screenshot and put it into your running Word document and put a title like this slide example, using AND to check for values within a range. Continuing on, the next connecting word that we have for conditions is OR. OR is used when we want to check if either one of the two conditions is true. So we want to do something when the first condition is true, when the second condition is true, or when both conditions are true. We are not going to do what is inside that condition combined with OR, only when both conditions are false. So we need either one of the two conditions to be present or both. For example, we may want to check if a value is divisible by 5 or divisible by 10. So only one of two being true, it is acceptable. I made a typo here, so I apologize. I don't want to redo all this. So here, this should be just 0. Okay, so scratch that too. Okay, so it should be if a value modulus 10 is equal to 0, it means that the number is exactly divisible by 10. Next conditions, if a password starts with a letter upper or lowercase, so within the uppercase letters or within the lowercase letters. So we connect those two conditions. When we know how to spell it out, we will connect those two conditions with the OR keyword. Next example, if the weekly worked hours or the hourly pay is 0. So not only when both are equal to 0, but either one being 0 is sufficient for me not to want to do the calculation, because the result of multiplying any number by 0 is going to be 0 pay. So I want both values to not be 0. So if weekly worked hours or the hourly pay is 0, then I don't want to do the math. Next example, if the average of the quizzes or the average of the labs. So now I don't need the students to have 100 for both the quizzes and the labs. Just having 100 in either one, it will exempt the student from attending an extra credit course or hour, or give an extra credit exercise or something like that. Don't get any funny ideas. I don't give extra credit. And finally, if a value is outside the range 0 to 100. So when we check within the range, we use AND to connect. When we want to check if the value is outside of the range, we connect less than 0 or greater than 100. So we would say something like if grade is less than 0 or grade is greater than 100. Why is that? Because we cannot have any number fulfill the combined condition less than 0 and greater than 100. There is no number in the universe of numbers that can be simultaneously lower than 0 and at the same time greater than 100. So when we want to find out if a value is outside a range, we use the less than the starting value or greater than the ending value. And that will check if the value is outside of the expected range. Here we have the example that you're going to do to practice the use of OR. We're going to use it to validate input. So with exactly the example that I was just telling you, to find out if a value is outside a range. So this is the same program as before. You can edit the program that you were working on to convert from the ASCII code to the character. But notice that rather than check in first if it is within the range, I want to check if it is outside the range. So a lot of times you may want to change the order of your code because once that the first one is true, the second one doesn't execute. So you normally code first the one that is more likely to happen. That way you don't have multiple times going through the same code, checking for things that you know are not going to happen. I don't know if that made any sense, but you know, experience will tell you how to do it. Right now, we're just practicing every single mode, so you see how it is set up. You can recycle the earlier program. You may want to save as rather than saving it, and when you're done, take the screenshots and paste it into the Word document with the title using OR to validate input. So notice the code. Print, type a number between 65 and 90, and I will tell you what letter it is. So this program does the same as the other one, but it checks if the input is wrong first, rather than checking if the input is right. So the code equals from the input, what is your number 65 to 90, and I convert the code to an integer. So the first 3 lines of code are exactly the same. We go to the condition, to the if statement, and we are notice what we're doing. We're reversing the symbols. Code less than. So this is the only symbol that you didn't have present in the condition before. Before it was greater than or equal to 64. Now we're asking for less than. So the opposite symbol, meaning the symbol that was not present out of the 3 common ones, right? Greater than, less than, and equal. So you reverse the symbol that compares to 64. You change the keyword from and, you change it to or, and then we check if code is greater than 90. So before we were checking if it was less than or equal to 90. So the symbol that was missing, the opposite symbol, is the greater than. And that's what you type in. Colon. And now this is the wrong input. So we display, sorry, your value is not between 64 and 90. Else means that's the alternative outcome, meaning that the value is correct. So we say that the uppercase letter equals the char of the code, and we display the code, the equal sign, and the uppercase letter that we have just converted to. Then regardless of whether the guy typed in the wrong value or the correct value, we're going to thank them for using the program. So here you have the output. Type a number between 65 and 90, and I will tell you what letter it is. What is your number? 65 to 90. So I typed in the wrong value, 60, and it says, sorry, your value is not between 64 and 90. When you run it also using values that would be correct. When you're done, take the screenshot, put it into the Word document, and we're moving on to the next. So these 2 exercises that you have just coded, they are checking for the opposite, right? The first one checks if the value is within the range. The second exercise checks if the value is outside of the range. We could have used the word not. There is the keyword not that you could have put in front of the condition that checks for the correct input. And if you just put the not in front, it checks for the wrong value. So not the right value means the wrong value. Well, what happens is that if we use not, it's very difficult to find it in the code. So we try to avoid it. So let's see what I have written here. A value is within a range, example, a grade between 0 and 100 when both conditions are true simultaneously. If grade is greater than or equal to 0 and grade is less than or equal to 100, that is the combined condition to check if the grade is a valid number 0 to 100. When we want to check if a value is incorrect, we would be inclined to use the not operator in front of the combined condition. That would make the program work correctly, but it will be very difficult to read, so we want to avoid that. So if for the time being, while you're getting used to this, if it is difficult for you to ask if the value is wrong, so outside the range, if that is a little difficult at the time, what you can do is exactly what I was telling you orally as I was reading the code. You look at the condition that checks for the value to be within the range. So for example, if grade is greater than or equal to 0 and the grade is less than or equal to 100. And I was telling you what we do to check for the opposite. We convert greater than or equal to the opposite symbol, which is the symbol that is missing out of the 3 common symbols. So in this case, we would spell out if grade is less than 0. The keyword and needs to be changed to or, and then the second condition, you're going to reverse the symbol. So if you had grade less than or equal to 100, you use the complementary symbol, which is greater than, and there's your condition. So these two conditions that we have spelled out on this slide check for the opposite. The first one, if grade is greater than or equal to 0 and the grade is less than or equal to 100, checks for a number within the range 0 to 100. The next one is the opposite expression. It checks for a value that is outside the range. If grade is less than 0 or grade is greater than 100, it means that the value is not within the range. So that's how you create the opposite expression without using not. So here is your next exercise. We are checking for a grade out of range. It's very similar to the exercise that you did before, but it has a new trick in your bag of tricks. So you're going to see that there is an if-else statement inside an if-else statement. When we write an if inside an if or inside the else of an if, like in this example, we call that nested if statements. So what is it that we're doing here? Well, we are asking the user to type a grade 0 to 100. We accept the input into the variable named score. We convert the score to an integer and we store it in the same variable so we can use it in the conditions. We check if the value is outside the range 0 to 100. So if score is less than 0 or score is greater than 100, colon, that would be an error. So we would say, sorry, you gave me a grade outside the range 0 to 100. Else, so if the value is correct, then I'm going to do something with it. So if the value is correct, I'm going to check if the person pass or fail. So if the score is greater than or equal to 70, congratulations, you passed. Else, sorry, your score is not high enough to pass the course. So if a person accidentally typed in negative 70, then we're going to say, sorry, you gave me a grade outside the range, rather than saying, sorry, you didn't pass the course. Why is that? Well, this will be valuable because maybe the person accidentally typed in a hyphen that represents negative, but the person scored 70. So for that reason, we check first if the value is incorrect, we don't do anything. If it is correct, then 0 to 100, the person could pass or fail. So we code that pass or fail inside the else in this example when we know that the value is within the legitimate range of values for grades. And regardless of whether the input was correct or incorrect, we display Mahalo afterwards. I have run this program using 200, which is an incorrect value. You should run it with also with a correct value that is below 70 or a failing grade, and a value that is within the correct range 0 to 100 that is also a passing grade. So you see how the program executes differently with all the different values. So when you're done, take a screenshot, paste it in your Word document, and the title for this is checking if a grade is out of range. Maybe in parentheses, put nested if statement, which means an if inside an if. Okay, so that is all the information that I wanted to cover this week about the if statements, which is quite a bit, right? So how to write the condition, what is the syntax of an if statement, the difference between multiple if statements or having the if-else-if structure, how to use and, how to use or, and finally, a short example, a quick example, so you realize that you can have an if inside an if and how it would be spelled out. Now we're going to focus on random integers. So we're going to have a little bit of fun because random numbers allow us to have the program run with randomness. So what is it? A random number can be used to get different values that are generated by the computer rather than we as a programmer hard coding the value, such as saying grade equals 100 or prompting the user for the value. So rather than doing either one of those two methods of having values in a program, we are learning a third way to get a number, which is to have a computer randomly generating the number for us. There are different kinds of numbers and different styles of generating random numbers. We're going to use the simplest style for random number generation without getting into details of how they work, how this programming language generates it, because that's for a more advanced level. And the random numbers that we're going to use are integer numbers, so we can check for equality and so on. So why do we use them? We use them to test a program multiple times without having to type the input. So you can, if you have an interactive program, you can comment out the interaction. So when you run it, you don't have to input each value. You can have the computer generate those random numbers for you, and the program will work faster, and you are going to see how it works with values that perhaps you don't even think about typing in. So to test a program multiple times without having to type the input yourself, to generate random passwords. So we're going to see how we can generate random integers for the codes, and then the codes, we have seen how we can convert them to characters. So that is the logic behind the generation of random passwords. Or to play games of randomness, like rolling dice. So we're going to see how we can have the computer play against us, and since there's randomness for both, instead of actually rolling a physical die, each one of us, we're going to have the computer generate a number 1 through 6, representing the faces of the dice. So how do we code that in Python? There are two things that you're going to have to remember. Before being able to use the command line that allows you to generate a random number, you have to use a new line of code that we haven't ever seen before that is called the import statement. So before using the correct command, we need to import the random library that has the commands that deals with randomness. And then we are going to generate as many random values as we need by the exercise that we're dealing with. We're going to use only integers. So here's your first practice exercise to generate random values. So this is the same program that you have just worked on but with the use of AND, right? So checking that the value is within a range. So what you're going to do, rather than input the values for codes to test the program, you're going to have the computer generate random numbers. So what you're going to do is grab that program that, not the last that you did, but the second to the last, where you had the condition if code is greater than or equal to 64 and code is less than or equal to 90. And here's an example how we comment out, we say. We put the hashtag in front of the lines of code that we don't want to execute. But we want to keep them there because we would do this as an exercise to test the program. So we would keep those lines of code as comments so they don't execute and it doesn't slow me down to test the program. And to be able to use random numbers, this is the syntax. We're not going to analyze it or anything. Import random. So that's going to be the first line of code in your program. This brings into your program the availability of the commands that you need to use in the next line. So the next line looks like this: a variable name code equals, and then this is the part that is given by the programming language, random dot randint. So randint generates a random integer, and that function expects inside the parentheses the starting value and the ending value. So we're asking Python to generate a random integer starting with 50 and ending with 100. And I'm going to display the code. I don't need to typecast it because I'm generating a random integer, so I don't need to typecast it to an integer. But what I need to do is, so I'm not blindsided, I want to see what number the computer generated. So print the code, and then if the code is greater than or equal to 64 and the code is less than or equal to 90, uppercase, this code stays the same as before. Uppercase equals the character of the code, so we typecast the code to convert it to a character, and then we display the code that was generated randomly by the computer, again, equals, and then the uppercase letter. Else, we're going to display, sorry, your value is not between 64 and 90, and then thank you for using, regardless of whether the code was within the range or outside the range. So the code, after you generate the random value, the code doesn't change at all. So all we're doing is using random number generation to modify how we get the value. So we comment out the lines of code that prompted the user for the value. We replace that, so speaking, with the import random statement, and code equals the random of the random integer that starts with 50 and ends 100, and we display it so we know what code the computer generated. I ran it twice, and fortunately it gave me a value that was outside the range, and immediately after it gave me a number that was within the range. So the first run, it gave me 64, and it told me, sorry, the value is not within the range. And then I ran it again, it generated 72, and it converted it to an H. And then regardless, in the two examples, it ends, the last line is thank you for using the ASCII code converter program. So modify that program, leave the lines as comments, just like I have it on the screen, run it. with multiple times, so you see how it gives you different letters if the value is between 60 and 90, and then play. Maybe change the random values, the 50 and the 100, and see what happens. Okay, so when you're done, take a screenshot, one screenshot of the code, and then multiple screenshots of the different sample runs, and you can crop that and just show me specific ones that they give you different outcomes. 3, 4 output are enough. And this is example 1 for random numbers. You can have a running number for the exercises. I lost count in which number of exercises we're in, but this is testing a program with random numbers. Here is your second example for random numbers. So we are going to code a simple game of randomness. So you know that a standard die has 6 faces with the values 1 through 6. And the simplest game that you could play is I roll a die, you roll a die, and whoever gets the higher number wins. And we can tie also. And normally, if in this case, rather than you playing against me, is the user plays against the computer. So it's kind of like if the computer is a casino and the user has a bank, a starting amount of coins or a starting amount of chips or a starting amount of dollars, whatever you want to call it. So we import the random generation library. We create 2 variables now, so 2 random values, one for the computer, one for the person, and the syntax is the same. What changes is the name of the variable. So what this does is, boom, it generates a random number 1 through 6, stores that value in the comp, short for computer. Next, it generates a random number 1 through 6, stores that value in the person variable. Now you have a value like 5 and the other one is a 2, and we need to see who wins. We start with a bank of 20 every time we run this program, and if the computer roll a value or got a value that is larger than the person's value, we're going to say that the variable name winner will read you lost, and the bank will get decreased by 2, because when we play against a casino machine, if we lose, the casino machine deducts our bank by 2. Else, if the person has a larger value than the computer, then the winner variable will have the string you won, and in that case, it's the opposite. Your bank gets increased by 2. So the value that you had in the bank receives 2 more. So the previous value of bank plus 2 means that you update the value of the bank by adding 2. Any other situation will mean that neither the computer wins nor the person wins. So what is the other alternative that we have? Any other situation, it means that both were equal to each other, so it's a tie. So in the winner variable, rather than you lost or you won, we have the string we tied. And then we display the value that each one has. So the computer rolled comp, display you roll person, the value that was randomly generated will display, and then we display winner. So rather than having to write another if statement, what I did was I put a statement that had to do with who the winner is in the variable named winner. So now if the person won, it's going to read you won exclamation point. If the computer won, we're going to see you lost. And if there is a tie, we're going to see we tied. And afterwards, you have this much money in your bank. So on the right hand side, you see my sample runs. I just run it twice, and I have one that the computer wins and one that there is a tie. You folks run it as many times as necessary so you get the 3 possibilities: winning, losing, and tying. So computer roll a 5, you roll a 2, you lost because the computer got 5 and 2, you got 2, so you lost, and now you have 18 in your bank. So you started with 20, now it went to 18. And when I run it again, unbelievably, I got a tie, so 2 and 2. So we tied is what is displayed, and then the money stays intact. So somebody asked me when we had the online meeting if we could rerun the program using the updated value of the bank. And yeah, you could. You know how? What we could do, rather than starting with bank equals 20, you can make that value interactive. So the first time that you run it, you have something like bank equals input, how much money do you have in your bank? And you would type in 20. And then the next time you run it, depending on whether you won or you lost, you start with 18 or you start with 22. And every time you run it, you would have to type in the value. It may seem that people could cheat, right? But because you run it again rather than keep running it as a loop, because you run it again, it will be the equivalent of, I was telling my students in the class, it would be the equivalent of being in a Vegas machine and deciding to change the machine. So you print the ticket, then you go to a different machine. So you either put in the ticket that you printed with the updated value, or you put in a dollar bill there. So that would be the input. It's a different kind of input. It is read from a ticket or it's read from cash. We are making it so it's interactive and you type it in. So you could do that. You can customize this program so it's interactive and the value of the bank is entered every time you run it, and you keep track yourself. What is the value that you got? Did you win? Did you lose? So then you start with the updated value of the bank and you can continue to play. Next week, when we learn to loop, we're going to continue to play until we reach 0. So as long as the bank has more than 2 or more dollars, we can continue to play. But that's next week. So please code this, take screenshots, put them in your Word document, and we continue to the next example. Okay, so before we can generate random text, let's take a side note about how we can work with strings and what happens when we add strings together. When we use the plus symbol to add strings, we do not do the mathematical addition, but we can use the plus with strings, and the action that we perform is called concatenation. We concatenate, and at that moment, the plus symbol is the concatenator. So before coding the program that generates actually a 2-letter random word, which is not a word, but we'll see, let's examine this. If a program has word 1, word 2, and word 3, so in word 1 we store CAR, and in word 2 we store ing. We can add word 1 and word 2, so we can concatenate them, and what it means is that whatever is in word 1 is car, whatever is in word 2 is ing. We're combining them together and it will make the new word caring, and it's going to be stored in word 3. Let's code something that is a little more realistic than this. And this is going to be your next exercise that you're going to paste in your Word document. So this is how we concatenate strings. So this that's going to be the title. The typical example would be having the last name in a variable, the first name in a variable, and then combining those two with a comma in a variable that we call full name. So we can ask a person for the first name, store it, ask the person for the last name, store it, and then combine those two into a variable that holds the last name, comma, first name, so we can then put that in a file for a roster for an instructor or something like that. So notice the example on the left. Last name equals Kahanamoku, first name equals Duke, full name equals whatever is in last name plus the comma with a space after plus whatever is in first name. When I display the first name, the last name, and the full name, I'm going to see, for this example, Duke on the first line, that's for the first name. Kahanamoku is the last name. And then full name has the Kahanamoku, comma, space, Duke. So this is an example of concatenation that deals with names. So you're gonna code that, you're gonna run it, and you're gonna paste it, and you can do it replacing Duke Kahanamoku with your own personal information, so it's customized to your own. The next example for concatenation, and it's very common, is area codes, the first 3 digits of a phone number that it escapes me what that's called and I either want to research, and then the last 4 digits of a phone number. So let's say that this could be a program for a cell phone company that generates phone numbers. So the area code is going to be given because the person hires the phone number here in Hawaii, and then the first 3 digits is also given by the store where it is registered, and then the last 4 digits are randomly generated until we find one that works, right? That is not taken. So once that those are correct, then the final phone number is going to be the concatenation of all those 3 parts. So we're going to display the area code, display the first 3, display the last 4, and print the phone, which is the concatenation of the 3 parts of the phone number separated by hyphens. So notice the output, 808-555-1234, and then the phone, the full phone is 808-555-1234. So that's what the variable phone looks like in memory. So code those 2 programs, put the title string concatenation, and paste your screens with your own examples. Okay, so we have used this earlier in this presentation, but let's review the ASCII code table, how it is organized, and here you have it if you couldn't visualize it earlier, that this yellow area is where the uppercase letters are. So you see that the starting value for the uppercase alphabet is the numeric value 65, and the letter Z has the numeric value 90. Remember that the ASCII code table that we're using in this class has the code represented in 4 different styles, and the decimal numeric format is the very first column. So you look at the first column, and the red is the character that is represented by that. So when we were checking if the code was within the range 65 to 90, then we wanted to run it because we wanted to see an uppercase letter. So now we're going to see how we can randomly generate that. So how can we randomly generate numbers? We generate any number 65 to 90, and then we can convert that to a character using typecasting. That's why I gave you those examples before. So now in this example, the only new thing is going to be that we're getting the random code, and we're converting that to a character, and then we're going to add that character to a string. So the algorithm for a program that generates 2 random characters and store them in a string, we need to generate a random code, convert it to a character. We copy that character to a string because it's the first character. We store that into a string. And then we're going to generate the second random code. We're going to convert it to a character, and we're going to concatenate using the plus symbol to the string. And then we're going to display the string, the word. Okay, so notice the code on the right and almost goes in parallel. So generate the random code is we need the import statement. The import statement is used only once at the beginning of the program to bring into our program the functions that relate to randomness. So we bring that in only once. Do not import that for each value that you want to generate randomly. So once at the beginning, now you have it available and you can code using the random.randint statement. So we import that, then we say the code equals random.randint, and we start at 65 and we end at 90. And then we say that the letter equals the character of that code. And now we're going to store that letter into the word. So we're going to say the word equals the letter that we have just found out. Why do I do that? To save the letter into a variable that is going to be string, because I'm going to recycle that letter variable. So I don't want to lose what I have just figured out randomly. So we generate another random code, we convert that new random code to another character, and now we concatenate that letter to the end of the word. So word equals the word that I had, which was 1 character long, plus the new letter. When we learn to loop, we're going to use this code to generate a random password of 8 letters. So, but I don't want you to get into the bad habit of copying and pasting the same code 8 times, because we have a control structure for that is going to make your code much slicker. So I'm asking you to do 2 so you see the foundation for the program we're going to do next week. So now we're going to display your random 2-letter string is the word, and when we learn to loop, we will generate an 8-letter password. Sorry that got cropped out. So please code that, take a screenshot, run it several times so we see several random 2-letter words generated. So run it maybe 3-4 times. We need the code only once, and the sample runs 4 or 5. It's not going to take you that much time. Here you have a couple links that you can use if you want to see some sources different from my lecture for the if statements. This open book project has the syntax for everything that we have been working on. It's presented in a very simple manner, so you can even get ahead and learn some more with very simple directives, or you can review from a different point of view. And then here you have a guessing game, which would be another way of using random numbers. The computer generates a random number and you are going to try to guess it, and the computer will tell you if it is lower, if you need to guess a higher value or a lower number. So but it incorporates a loop. That's why I didn't use it this week. So folks, that is it. It was a lot, an hour and 18 minutes long presentation, but totally worthwhile. And I hope that you are clear about the use of the if statements and you can have a little bit of fun using random numbers. Please practice as much as you can, and then we can build that foundation from the knowledge that you acquire from your exercises. Ta-da! See you later.